Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics, class 10, chapter number 12, electricity. Topics 12.3, circuit diagram. Under this topic, we are going to learn symbols of some commonly used components in circuit diagrams. And 12.4, Ohm's law. Under this topic, we are going to see activity for Ohm's law. At the last, resistance. The last class we have seen about electric potential, and also I given some questions for homework. I given these 6 questions. Now I am going to discuss the answer for these questions. The first question, define electric potential. So what is meant by electric potential? If you need to move a unit charge from one point to another point. So if you want to move a charge from one point to another point, we need to work. That is called electric potential. The electric potential difference between 2 points in an electric circuit carrying some current is the work done to move a unit charge from one point to another point. The potential difference between 2 points equal to work done by charge. The potential difference is represented by the letter capital V and work done equal to capital W, charge equal to capital Q. The very important word is work done to move a unit charge from one point to another point, that is called electric potential. The second question, write the relation between work W, charge Q and electric potential V. The answer is V equal to W by Q. This is a relationship between work W, charge Q and electric potential V. The third question, write SI unit of electric potential. The SI unit of electric potential is, you know that, W by Q. The W equal to work done. The SI unit of work done is joule. The SI unit of charge is coulomb. So the SI unit of potential difference is joule per coulomb, or the SI unit of potential difference is volt. There are the two SI unit of potential difference. One is joule per coulomb and another one is volt. The fourth question, define 1 volt electric potential. One volt is the potential difference between 2 points in a current carrying conductor. When 1 joule of work is done to move a charge of 1 coulomb from one point to another point, then the electric potential is said to be 1 volt. That means we know that V equal to W by Q. If 1 joule of work is done to move 1 coulomb of charge means, then the volt is said to be 1 volt. When 1 joule of work is done to move a charge of 1 coulomb from one point to another point, then the potential difference is said to be 1 volt. The next one, name the instrument used to measure electric potential in a circuit. An instrument, voltmeter, measures electric potential in a circuit. This is a voltmeter. If you connect the voltmeter in a circuit, we can measure the electric potential difference between 2 points. The next question, how is voltmeter connected in the circuit to measure electric potential difference? Look at this diagram. Here the voltmeter is connected across between the 2 points. So the voltmeter is always connected in a parallel across the point between which the potential difference is to be measured. Dear students, I hope you understood the answers. If you written wrong, please correct it. The next we are going to see today's topic. The first question, what is meant by circuit diagram? In a lower class, you know that the circuit diagram, you are drawing the circuit diagram. So what is meant by that circuit diagram? A circuit diagram, also known as electrical diagram, electronic schematic diagram, is a simplified conventional representation of electrical circuit. So the circuit diagram is nothing but a circuit diagram is also known as electrical diagram or electronic schematic diagram. It is a simplified conventional representation of electrical circuit. Why I am saying that it is a simplified conventional representation of electric circuit? We will see the meaning of these words in the next slide. Symbols of some commonly used components in circuit diagram. It is often convenient to draw a schematic diagram in which different components of the circuit are represented by the symbols conveniently used. Example, if you know that this is cell, it has a positive terminal and negative terminal, and this is bulb. Now I want to connect these two components in the circuit. So I simply draw the diagram. The cell positive, negative, and the wire is connected to the bulb positive and negative. So using the components, that if you using the components, we can't draw the schematic diagram. Using the symbols, we can draw the schematic diagram. So it is convenient to draw a schematic diagram in which different components of the circuit are represented by the symbols conveniently used. Conventional symbols used to represent some of the most commonly used electrical components are given below. So these are the normal components we are used in the circuit diagram. In an electric cell, it is represented by the symbol this. Then battery, plug key switch is open and plug key switch is closed. Switch is closed means one dot you want to put. The wire joint, when the two wires are joined together, you have to mark in this way. Then wire crossing without joining. The two wires are not joining means you have to put this curve. Then electrical bulb, a resistor of resistance, variable resistance or rheostat, ammeter, voltmeter, fuse. So here I given some components name and symbols. Using these symbols, we can draw the schematic diagram. Don't use the components. Wire, This is a component of wire. This is a symbol of wire. Cell. This is a component of a cell. This is a symbol of electric cell. It has a long terminal. The long terminal is positive. The short terminal is negative. So you have to draw positive and negative. See, this is a positive terminal and negative terminal. This cell is represented by long line and short line. The next one, voltmeter. The voltmeter means we represent voltmeter. It has a two terminals, positive and also negative. So you have to represent positive and negative. This is a component of voltmeter. This is a symbol of voltmeter. The next one, ammeter. The ammeter is represented by the letter A, and it also has two terminals, negative and positive. So I written positive and negative. This is a component of ammeter. This is a symbol. The next one, galvanometer. Till now you know ammeter and voltmeter. The ammeter is used to measure electric current and the voltmeter is used to measure electric potential. So what is meant by galvanometer? Galvanometer is nothing but it is used to detect the presence of current, whether the circuit having current or not. How to check? Using a galvanometer we can check whether this circuit have current or not. So it is used to detect the current in the circuit. So the galvanometer is represented by the letter G. So I written G. It also has two terminals, negative and positive. So I written negative and positive. And this is the resistor. The resistor is represented by the symbol. Like that you have to draw first straight line. Then see here, this line and this line should be straight. So this is a symbol of resistor and this is a component of resistor. So when you are drawing the resistor, first straight line, then these two are in a straight line. The next one, a rheostat. This is a rheostat. It is represented by the symbol. This is a rheostat symbol. Here I given one arrow mark. The arrow mark is nothing but we can change the resistor value. So this component is represented by the arrow mark and this resistor is this symbol. Are you understand? This is a rheostat and otherwise we can call it as variable resistance. The variable means you have to put on arrow mark in this direction. The question, draw a symbols of some commonly used components in circuit diagram. I hope you understood what is meant by circuit diagram. The circuit diagram is used to using symbols we can draw the circuit diagrams easily and also we can understand easily. I hope you understood why we are using the symbols to draw the circuit diagram instead of components. Because if you draw the components in the circuit, it take more time and also it occupies the more space. Instead of components, we can use the symbols to reduce the space and also we can understand easily. The next topic is Ohm's law. Till now you know that what is meant by electric current and electric potential. The electric current is nothing but a flow of electric charges constitute electric current in the circuit when the charges will flow from one atom to another atom when we given the potential between 2 points. So you know electric potential and also electric current. Without electric potential there is no electric current in the circuit. So is there any relationship between the potential difference across the conductor and the current through it? So any relationship between the potential difference and electric current? Let us explore with an activity. Now we are going to see whether it has a relation or not. For the aim of this activity is to show that the ratio V by I is constant for a conductor. This time I will explain you at the last. The ratio V by I is constant for a conductor. How? The required materials for doing this activity is 5 tri cells of each 1.5 volt. You know that the cell means this is a cell. We need 1.5 volt 5 cells. So that means 5 tri cells each having 1.5 volt. The next one, connecting wires. The connecting wires. Then ammeter. Then voltmeter. The nichrome wire, key. The nichrome is nothing but it is an alloy of nickel, chromium, manganese and iron metals. This is a very important question. What is by nichrome? The nichrome is an alloy of nickel, chromium, manganese and iron metal. Are you understand what is the aim of this activity? We are going to show that V by I is constant for a conductor. For doing this activity, we have to take 5 tri cells of each 1.5 volt, connecting wires, ammeter, voltmeter, key and nichrome wire. Procedure for doing this experiment is, first use only one cell as the source in the circuit. So here I used only one cell. The cell means it has a positive terminal and negative terminal. The long terminal is a positive, short terminal is negative. So first use only one cell as the source in the circuit diagram. And see here, this cell is connected to, this is a nichrome wire and the ammeter is connected in the series and key. Here the voltmeter is connected across between the two ends of the nichrome wire. See here, the positive terminal of the battery is connected to the positive terminal of the voltmeter and positive terminal of the ammeter and voltmeter. The negative terminal of the ammeter is connected to negative terminal of the battery. The same as here, the voltmeter negative also connected to negative terminal. So when you are drawing the circuit diagram, you must check it. The positive terminal of the battery must be connected to positive terminal of the ammeter, positive terminal of the voltmeter. So here I used only one cell as the source in the circuit diagram. So now the circuit is a complete circuit and closed circuit. When I switch on the battery, the current is constituted in the electric circuit. So when the electric current is flowing in the circuit, the ammeter shows the electric current value and the voltmeter shows the potential difference across the end of this point. So note the ammeter, note the reading in the ammeter I for the current. The reading of voltmeter V for the potential difference across nichrome wire in the circuit. So you know that here I connected only one electric cell. So the voltage must be 1.5 volt. So the voltmeter shows 1.5 volt. And the ammeter shows 2 ampere. Simply I say that 2 ampere. It may be varying. For your understanding, I am saying that V equal to 1.5 volt, it is correct because we connected only 1.5 volt battery. But here an ammeter, I took the value 2 ampere. The SI unit of current is ampere. So I written ampere. The SI unit of potential difference is volt. So 1.5 volt. The next connect two cells in the circuit and note the respective readings of the ammeter and voltmeter for the value of current through the nichrome wire and potential difference across the nichrome wire. Here I connected one more cells. Now the circuit is a closed circuit. I took the reading in the voltmeter and ammeter. Now the voltmeter reading is 3 volt because 1.5 plus 1.5 equal to 3 volt. The ammeter shows the reading 4 ampere. In a first one, the ammeter shows 2 ampere, the voltage is 1.5 voltage. When I connected the two cells, the voltage also increasing, the current also increased. So from this we can say that the potential difference is directly proportional to the current, or the current is directly proportional to potential difference, because when the potential difference is increasing, the current value also increasing. When I connect the two cells, the current value is increased. Repeat the above steps using 3 cells and then 4 cells in the circuit separately. So here I connected the one more cells and tabulate them in the table given. Calculate the ratio of V to I for each pair of potential difference V and current I. When I connected the 3 cells, I calculated the value of current I and volt V. And I put a tabulation. Here first serial number of cells used in the circuit. In a first circuit, I used only one cell. I measured the current is 2 ampere. The potential difference is 1.5 volt. Where in the first circuit diagram, see here, the first circuit diagram I used only one cell. The current value is 2 ampere. The voltage is 1.5. In second serial number, I used 2 cells. The current is 4 ampere and potential difference is 3 volt. In a third one, I used 3 cells. When I connected the 3 cells, the current is 6 ampere and the potential difference is 4.5 volt. When I used 4 cells, the current is 8 ampere and potential is 6 volt. Now I am going to calculate the value V by I. So the aim of our activity is to calculate the ratio V by I for conductor. So here in the first reading, the V is 1.5, the I is 2. So 1.5 by 2 equal to 0.75. In a second reading, the value of V is 3 and current is 4. So 3 by 4 equal to 0.75. In a third also I calculated, fourth also calculated. At the last I have get 0.75. So the V by I equal to constant. From this I can say that V by I equal to constant. Why I am saying that constant? Because I get the constant value for all the readings. Whatever may be the value of reading, I can get the V by I value is constant. Dear students, please check it whether it is correct or wrong. So now you understood. From this we can say that the ratio of V by I is constant. Why I am saying that it is a constant? Because I can get the constant value for all the readings. Now I am going to draw a graph for these values. For plotting graph, you know that you have to take a graph sheet and draw x-axis and y-axis. The current values are taken as x-axis and potential difference is in a y-axis. And here the value of current is 2, 4, 6, 8. So I taken the value 1, 2, 3, 4, 5, 6. And the potential difference is 1.5 volt and 3, 4.5 volt, 6. So the minimum value is 1 point, the maximum is 6. So I took 1, 2, 3, 4, 5, 6, 7 values. After marking the point, I get a straight line. So from this we can say that the potential difference is directly proportional to the current. Are you understand? If you if you plot a graph between V and I get the straight line. From this we can say that the potential difference is directly proportional to current. That means when the potential difference increasing, the current also increased. So thus V minus I graph is a straight line that passes through the origin of the graph. So it passes through the origin of the graph. Graphically, I calculated the value 0.75. How? First, you have to draw a x-axis and y-axis and give the value of I and give the value of V. Then mark the point and draw a straight line. So, just I drawn smaller triangle from any space, any reading. Here also you have to take in a straight line from anywhere. Here also you can take, and here also you can take, but here now I taken the value for here. So I drawn simple triangle. It must be touched with this line. So I drawn the perpendicular line to x-axis and y-axis. Are you understand? Maybe if you drawn here, maybe if you draw here means you have to draw a perpendicular line to x-axis and y-axis. So here I drawn here the x-axis to y-axis. So here I took del V. The del V means the maximum value is 4.5 and the minimum value is 3. So V2 minus V1, the 4.5 minus 3 equal to 1.5. Then del I. The del I value, the first is 4, the next one is 6. So del I equal to I2 minus I1. The I2 value is 6. From this graph I took 6 and the 4. Del I equal to 2. Now the ratio del V by del I. The del V value is 1.5, the del I value is 2. When I divided 1.5 by 2, I can get 0.75. So graphically, I proved that V by I value is constant. Are you clear how I took I1, I2 value, V1 and V2 value? So in 1827, a German physicist George Simon Ohm found out the relationship between the current I flowing in a metallic wire and the potential difference across its terminals. So who found this relationship between potential difference V and current I? A German physicist George Simon Ohm, when in 1827. He stated that electric current flowing through a metallic wire is directly proportional to the potential difference V across its end, provided its temperature remains the same. This is called Ohm's law. It is a very important law. It gives the relationship between V and I. The potential difference electric current flowing through a metallic wire is directly proportional to potential difference across it end. And I given the one more word, temperature remains the same. If you are doing this experiment in the room temperature 37 or 36 degree, when we are increasing the voltage, the current will also increase. But if maybe the temperature is varying, maybe the room temperature is 100 or 120, means this Ohm's law is not applicable. That means when you are increasing the voltage, the current may be decreased or increased or not changed. So when the temperature remains constant, the voltage is directly proportional to I. That is called Ohm's law. So I can write V directly proportional to I, and when the I come to this side, we can write V I equal to constant. You know that V by I value is always constant. This constant is represented by the letter R. So V equal to I R. When the R will come this side, the V equal to IR. That means Vengatrama IR. In memory, you have store it. Ohm's law is nothing but V equal to IR. We can easily say that Vengatrama IR. That means V equal to IR. Where R is a constant for the given metallic wire at a given temperature. Why I am again and again saying that the temperature is constant, R is a constant for the given metallic wire at a given temperature, and it is called resistance. The name of the R is nothing but resistance. So this resistance value is always constant for a given metallic wire at a given temperature. Now we are going to see what is meant by the resistance. It is the property of a conductor to resist the flow of charge. So when we connected the resistors, the components, we know that the resistor is nothing but it was in this shape, we drawn in this symbol. So it is a property of a conductor to resist a flow of charge. When we connected the resistor in the conductor, it resists the flow of electric charge. And the resistor is nothing but like a speed breaker. When we are putting the speed breaker in the road, the speed breaker reduces the speed of the vehicles. The same also when we connected the resistor in the circuit, It resists to flow of electric charge. And the resistance also have a unit, that is ohm, because this was discovered by the Saj Simon Ohm. So the unit of resistance is ohm. It is represented by the letter in this letter. According to Ohm's law, V equal to IR, R equal to V by I. When we are rearranging this equation, we can get R equal to V by I. So the R is nothing but it is a property of a conductor to resist the flow of charge. It also has a SI unit ohm, and the letter, it is represented by the letter ohm. Now what is meant by 1 ohm? You know that R equal to V by I. When the potential difference is 1 volt, the current is 1 ampere, then the resistance is 1 ohm. So if the potential difference across the two end of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is 1 ohm. That is 1 ohm equal to 1 volt by 1 ampere. Questions for today's homework. Define Ohm's law. Write the necessary condition for its validity. State the law that gives the relationship between the potential difference V across the two end of a conductor and the current I flowing through it. The third question, what will be the nature of a graph between potential difference and current for a conductor? Name the physical quantity that can be obtained from this graph. The fourth question, how is this law verified experimentally? The fifth question, define electrical resistance of a conductor. The sixth question, write SI unit of R. The seventh question, define 1 ohm. Thank you for watching. Thank you.